Hi everyone, it's Sorkin. Today we have a problem when we are given n as an input and we need to return the number of strings with the size of n, with the length of n, and also which are lexicographically sorted. So for example, the first case, right, the n is equals to 1 and the number of strings that are lexicographically sorted is only 5, right? We have 5 vowels and the A, E, I, and so on. So about the second case, if I is n equals to 2, there are 15 strings that are lexicographically sorted and the vowels and with the size of 2, with the length of 2. This is AA, AE, and so on. We're going to solve this problem using a backtracking approach. In the backtracking, the most important thing is to exactly visualize how tree is going to be generated. So let's take the example n equals to 2, right? And let's generate the tree for it. So in our case, our base case is that if when our when our length of our string is equals to n, right? So let's generate our tree, how exactly it's going to be generated. So for example, let's say for A, right? For A, first we are going to explore A and A, right? It's the one case. So since the size is equals to n, equals to 2, we are backtracking from here. The next one is we are checking A and E, right? So again, we are backtracking from here. The same we are doing for A and I. And we are doing for A and O. And we are doing, the next one is for A and U, right? So we have explored all the options that we had for A. Now we are going to the next element. The next element in our case is E, right? So the next element is E. So for E, since our string should be sorted lexicographically, so which means that by numbers and letters, in our case by letters, so we are not considering A because it comes prior to E, right, in alphabet. So we are taking the next letter. So we are taking E and E. The next one is gonna be E and I, and so on. That's how we are going to generate our tree. Okay, first thing that we are going to do here, we are going to create a result, which is we are going to return. Let's return our result. And next one, let's create our backtracking method that what we are going to pass here. We are going to start from 0, right, from the first letter. We are going to pass the size of our string, and we are going to pass our result, right? And now let's implement our backtracking method, which returns void backtracking, and it's gonna take L letter, the letter that we are from where we are starting. So right, the size of our string, and it's gonna take int. It's gonna take our result. Okay. Now let's do following. So we are going to do reverse, right? So what we will start from the first letter as we progress as we go to the next layer as we are going to the next layer in our backtracking tree, right, that we are generating, we are going to decrement from n. By the time when we have a string with the size of n, this n will be equal to 0, right? It's going to be equal to 0. So for that, what we are going to do, our result, we are going to increment it, and we are going to backtrack from that tree, from that branch. Now let's implement our backtracking, which is int I is equals to L, I is less than, so we have only 5 letters, right, 5 vowels, so less than I, so we are exploring 5 options, and I plus plus. So, and we are calling our backtracking. We are calling our backtracking. We are passing I, we are passing n, but n minus 1, right? And we are passing our result. Okay, all right, let's run it. Okay, here we are passing, okay, let's correct it actually quickly to array. Here we are passing not the value. Here we are passing not the reference, but the value of result. So let's just quickly change it to array. I think that would be very quick. So let's take it 0 and let's pass here array. Okay, let's run it. Okay, great. It works as expected. Let's calculate the time and space complexity. The time complexity in this case, it's off since it's backtracking, right? It's exponential, and we are making 5 choices right here. So our time complexity is gonna be 5 of n, right? 5 of n. How about our space complexity? Space complexity is determined by the depth of our recursion, and in the worst case, it's gonna be of n. So it's gonna be n, the size of our input. So it's of n. Okay, that's it for today. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.